Hey guys, mathematicians like to make things simple. They don't like to complicate things at all. They like to simplify and make things easy, straight to the point, and smaller in writing. Now here we have algebraic expressions. Some of them are pretty long, as you can see, but mathematicians, they like to take shortcuts. So there are shortcuts, and there is what we call index notation. So writing these algebraic expressions in a much simpler and shorter manner. Let's see how we're going to do it. We use algebra and the skills in algebra to shorten these expressions. Now, index notation is going to be used. Remember that term, index notation, because many times you're going to be using it to simplify and make things you make your answer simpler and easy to read. Now here we have b times b, which means, like in numerals, 8 times 8, or 5 times 5, or 10 times 10. We know numerals, we write them down in simplest form. So 8 times 8 will be 8 squared. 5 times 5, 5 squared. 10 times 10, 10 squared, or 10 to the power of 2. Well, in algebra, the pronumerals behave in exactly the same way. They are, or they can be written in a short form. Let's see how we can do b times b. b times b, well, is b squared. Like we said, 5 times 5 is 5 squared. Algebra, the pronumerals behave exactly the same manner. b times b, b squared. This one here, c times c times c. What do you think is to happen? How many c's are there multiplying each other? There are 3 c's. 1, 2, 3, c to the power of 3. It's that easy. Next one here, x times c times x. Okay, we have two different pronumerals. We have the x's and the c. Well, let's start with the x's first. X times x times x. There are 3 of them multiplied together, which means x cubed. And times c, and we just write c. We don't write the multiplication. In algebra, we always like to make things shorter. Multiplication is not written, but we know it's there. So x to the power of 3, or x cubed c, meaning x cubed times c. That's the short form, that's the index notation for writing that. Instead of writing it this long, we shorten it and make it simpler, x cubed c. Here, another long one, a times b times b times a times b. Well, let's make it shorter. We have 2 different pronumerals. We have the a's and we have the b's. Let's start with the a's. A times a squared, and the b times the b times the b, b cubed. A squared, b cubed. Look, it's become from something so long, a very simple and short answer. It means the same thing, but it's written in a much simpler format. Here, 4 times x times 3 times x times y. What do you notice? There are numerals, the numbers. So we have to multiply numbers first. Always numbers come first, all the time. So 4 times 3, we start with them first. We have 12. Then x times x, x squared, and y. Now notice how it's very important to differentiate between the times and the x. Times, times, x, times. Very important. That's why we write our x's in algebra in this way, like a C and a C backwards. Very important that you start writing it like that. It's critical, or else you will make mistakes because you can't differentiate between your times and your x. And x is a pronumeral that we always use. So get used to writing it in this format. That way you won't get mixed up and you won't make any mistakes. Here we have 6 times a times b times c times a. Again, it's pretty long. We like to shorten it and make it simpler. Okay, we have a numeral which is a 6. Does it multiply with any other numeral? No, there isn't any other numeral. So just 6, there it is. A times b times c times a. We notice that the a's, a times a squared and b c. 6a squared b c in index notation. Doing this one here, see if you can do this one yourself. Be quick. 5 times c times z times 4 times z. Okay. Do we have numerals? Yes, we do. 5 times 4, 20. Then we look for the pronumerals, c times z times z. So we can do the z's, means z squared, and then c. 20, z squared, c. Have we done it correctly? Yes, 5 times 4, 20. The c is already there, and z times z, z squared. Much simpler, much shorter than writing it in this confusing way. This is called index notation. Now looking here, it's been written in index notation. We would like to expand it and write it back in its original form. N cubed, meaning n times n times n. Why? N cubed, n times n times n. M squared times m times m. N to the power of 3, n times n times n. M to the power of 2, m times m. That's the original form. It was in index notation and we wrote it back in original form. X squared, y cubed, z squared. We know there's a multiplication. We always know that. Between the pronumerals, there's always a multiplication. If there's nothing there, we know straight away it means multiply. X squared times y cubed times z squared. Okay, let's do it. X squared meaning x times x. Y cubed meaning y times y times y. And then z squared meaning z times z. So here, one long answer. It was in an index notation. We expanded it. X times y times y times y times z times z. X squared, y cubed, z squared. Here, this is the basics. Index notation, you're going to see a very important topic we're going to learn later on called indices, and it's going to be using these foundations and these rules. So make sure you know this back to front. Indices is a big topic you're going to cover, and it's going to be introduced in years 8, 9, and 10. So it's very important that you get the hang of this and you master it. As you can see, it is simple, but the more practice you do, I've done several examples for you to get the hang of it. I always like to do examples for students. The more examples you see, the better you'll become. You may even want to replay this video to see how it's done again and again to make sure you master it, but it is a pretty easy concept, and if I can do it, that means you can too.